The southern hemisphere is not okay. Things happening in South America and more importantly Antarctica are not making as much news as they should be. The oceans around Antarctica and India, the Indian Ocean and Africa are way warmer than they should be, and each day temperatures seem to be rising. And remember, this is the winter in the southern hemisphere around the Southern Ocean and the southern part of Indian Ocean and around Australia and the southern part of Africa and South America. Australia is way warmer than it should be, as is South America, which seems to be on fire and burning in the midst of peak winter, hitting temperatures in the high 30s. Antarctica is of course facing the brunt of everything this year, and it is not an exaggeration to say that literally every single day brings news that is worse from the previous days. Now, ice the size of Greenland has melted in Antarctica, and ice the area of Mexico has not formed this year. The change of sea ice level is astounding and multiple times more than what scientists had predicted it would be this year. In the midst of all of this, and in the midst of a crazy week for physics, new data came up about the physics of Earth's energy imbalance, which has got scientists clamoring everywhere for people's attention even more. And now, forget 1.5 degrees at the end of the century, scientists have started to believe that we might actually hit a 2-degree rise in just a few decades. And what is probably happening at Antarctica right now could be a functional collapse of the Antarctic ice system, and its consequences are going to be more global and more immediate than we think. This graph is an important one to understand. For the past few years, temperatures have indeed been rising, and the physics of how much is calculated by knowing the radiative energy of Earth or its imbalance. It is known as the Earth Energy Imbalance, or EEI, which is defined as the difference between the amount of energy and heat entering the Earth system from the Sun and the amount that escapes from Earth to space. Earth's atmosphere traps heat and the surface and oceans absorb it. Energy radiates from Earth's surface as heat back into space. Radiative forcing is what occurs when there is energy imbalance, and EEI is positive when the Earth system is absorbing more energy than it is giving out. And of course, this is because of greenhouse gases. These gases trap heat, which prevents heat from escaping the Earth system. 2 years ago, in 2021, NASA came out with a study that found that EEI was in fact going up, but it had doubled. Earth was, in a manner of speaking, absorbing twice as much energy and heat as it was giving out. This data was acquired from both clouds as well as oceans. The scientists determined that the doubling occurred because of greenhouse gases, and it was also part anthropogenic forcing and part internal variability. They predicted that this will come down, but instead it started to go up. After the pandemic, after the entire world shut down for more than 4 months, the Earth became warmer than it was. Turns out this can be attributed as a short-term trend to the decrease in sulfur emissions from ships. These polluting sulfur particles are white in color, so they reflect sunlight in our atmosphere. Their loss causes a temporary rise in the temperature of the atmosphere. And then this was expected to come down, but it didn't. It rose way beyond expected, which is where we are now. The poles in general warm quicker, and at extreme temperatures like Antarctica's, the difference is very physically palpable and visible at really gigantic scales. This year, there is only 11.7 million square kilometers of ice, and nearly 2.5 million square kilometers of ice is missing. It isn't disconnected from the rest of the planet. Greenland also has lost more ice this year than before any other year, and we already saw last week how the increase in temperature was feeding forest fires and ocean warming in multiple countries. Ice researchers and climatologists and climate scientists now are calling attention to the fact that not only is there more melting and loss of ice at the South Pole, but the amount that is being lost is drastically steeper than it should have have been, and it happened in a very short period of time. It is double of what was expected from the past 40 years of satellite data that include the effects of climate and warming. This is also a vicious cycle because as ice floats off Antarctica, it breaks into chunks all over the ocean, surrounded by dark waters, and melts quicker. Greenland is facing this too, as is Canada, with giant blocks of ice creeping up to people's coastal houses. But Antarctica is even more unique because it recovers way slower than Arctic ice does. A loss of this scale as Antarctica is facing today could maybe not affect as much next year and more ice might form, but more likely than not will not be the case. The heating has been ongoing for a while, building up to winter. In peak winter, it seems Antarctica and the southern hemisphere in general is warmer today than summer would have been a few decades ago. Scientists started noticing the lack of sea ice in Antarctica as early as June this year, but it only has gotten worse since then. Floating ice and Antarctica play a crucial role in the Earth's climate system. Ice is white and thus it reflects more sunlight. This keeps the Earth cool. The cold also drives important oceanic currents which protect other icebergs in the surrounding areas. Every year, ice forms at one part of Antarctica and then melts from another. This year, February reached record low levels of ice, peak summer there, and ice should have started to form by now, peaking in September, which would be peak winter. In the winters, Antarctica typically recovers more than six-fold the ice that melted in February. But in the past decade, things have changed drastically, and this is having effects. The Antarctic ecosystem is a thriving one, and warm waters will kill many species that have specialized to survive this extreme cold. This will cascade up the food chain, such as the loss of krill for whales, and this will lead to a disruption in biological marine life. The loss of ice will raise up ocean temperatures, and the loss of large temperature difference between warm waters and cool waters will affect long-term ocean currents. And there is so much ice in Antarctica, it is hard to understand these levels. Literally, if all of the missing ice in Antarctica made up a country, it would be the 10th largest country on the planet today. And when this ice melts, coastal communities are killed. The increase, coupled with a warmer atmosphere, also gives rise to more extreme precipitation and cyclones globally. Things are changing drastically and very quickly at the South Pole. Specifically, this is observable in data from the past 7 years alone. At the end of 2016 is when things began to become extremely loud. February 2017 had a record minimum ice level, with each year following that breaking some form of a record. And through these years, the ice regrowth has fallen steadily. This year, it has fallen so beyond what was expected that even statisticians are now getting involved in contributing to the climate discourse with information. Antarctica is also extremely complex to model due to its sheer size and extreme temperatures, and scientists in general have had trouble predicting details about the climate system at the pole here. So, technically, given that information, it is still too early to conclusively say what the exact factors were for what drove this year's anomaly. But there is no doubt that anthropogenic change has played a major role in raising temperatures. And the effects of what will happen here are being seen and will be seen all over the globe.